here we go. Section 5.3 notes. So we're going to start talking about polynomial functions. And polynomial functions are just functions that are either they're in one variable. And what that means is that you're not going to have an x and a y. You're not going to have like a w, y, z. It means it's one variable. That means everything is in one variable. And up until this point right now, we've been doing one variables. So there's a couple different things you need to know. That polynomial should be written in standard form. Standard form is when the highest exponent is first and the constant term is last. That's how you always want to write it. And everything that we've written up until this point, well, today in class, we've been writing them in standard form. The degree of the polynomial is the value of the greatest exponent. And this is why it's really important that you know that we're only in one variable, because in section 5.1, I gave you more variables like in a monomial, and I told you to add up all the exponents to get the degree. Well, when you're in one variable, you only have one exponent for each term, and that's your degree. Okay, so the other thing you need to know is as long as you're in standard form, the coefficient of the first term of the polynomial, again, in standard form, is what we call the leading coefficient. Okay. So a number without a variable is called the constant. And notice that if this is the only term, your degree is 0 because you don't have a variable. That's the only reason your degree is 0 is because you don't have a variable. Okay. The linear 4x minus 9, because the x has an exponent of 1, that's your degree. And then 4 is your leading coefficient. You guys, there are quadratic, cubic, which you've seen. There's also quartic, which is your highest degree is 4. And then there's quintic, which is 5. We don't do a lot with those, but sometimes we do. Okay? And so now what we're going to do is we're going to look at examples 1, 2, and 3. So before you can tell me the degree and the leading coefficient, the first thing that it has to be is you have to ask yourself, is it a polynomial and is it in standard form? If it's not a polynomial, then you don't go any further. If it's not in standard form, then you need to write it in standard form before you find that degree and leading coefficient. So let's look at number 1. Is number 1 a polynomial? That's the first question I need to ask you. Is it a polynomial? It is not a polynomial. Oh my goodness, it is not a polynomial. Anybody know why it's not a polynomial? Yes, it is because of this term, because x is in the denominator of a fraction. And remember, in order to be a polynomial, no variables can be in the bottom of a fraction. Okay. So no, it is not a polynomial. 4x is not a monomial because x is in the denominator. And remember, a polynomial is a series of monomials being added or subtracted. Okay, so we can't do anything. We can't find the degree or the leading coefficient for number 1 because it doesn't even meet the basic need of being a polynomial. Okay, example 2. Is it a polynomial? Yes, it's a polynomial. Everything is no variables are in the denominators, and we have no negative exponents. Now, is it written in standard form? That meaning is the largest exponent first and then the constant term last. It is. It goes in order. Is that 6? 6, 4, 3, negative 14. So I'm going to ask you my degree. And remember, when it's in one variable, the degree is the largest exponent you see. And I'm going to ask you about the leading coefficient. So, what is the degree of this particular polynomial? Yes, it is 6. And then what is the leading coefficient? It is 5. So the degree is 6 because that's the largest exponent you see. The leading coefficient is 5 because that's in front of the largest variable exponent. So 5x to the 6, x to the 6th is the largest term exponent, and that's why the 5 is the leading coefficient. Number 3, is it a polynomial? Is it a polynomial? It is. No variables are in the denominator, so we're good. Is it in standard form? That's the next question. Standard form puts the largest exponent first. No. It is not. So we're going to need to rewrite it in standard form because you can't find your leading coefficient until it's in standard form. So it looks like negative x to the 6th plus 8x to the 4th minus 2x to the 3rd plus 3. You guys, please remember that when you go to do this on a test, I'm going to give you one that's not in standard form, and you're going to have to I'm going to ask you, what is the leading coefficient? What is the degree? And remember, they go hand in hand. Okay, so what is the degree of this polynomial? Six is the largest exponent, so that is my degree. And then what is the leading coefficient? The leading coefficient is indeed in front of the largest exponent, and it's a negative 1, so that is our leading coefficient. Okay. Now, let's talk a little bit about polynomial functions, okay? So, a polynomial function is continuous, is a continuous function that can be described by a polynomial equation in one variable. And you guys, again, that's like x to the 3rd plus 1, okay, or 2x to the 3rd plus 4x to the 3rd minus 2x squared, like it just goes on. Okay. So the other thing you need to know is that the simplest polynomial functions of the form y equals ax raised to the b, and a and b can't be 0, are called power models or power functions. In AP Stats, we call those power models, and they're called power functions. In Algebra 2, they're basically the same. Okay, so what we're going to do is we're going to plug some stuff into, we're going to substitute some stuff into a polynomial function, and we're going to get an answer. That's basically what we're doing. So on this example down at the bottom, I've kind of worked it out for you already, and what I just wanted to show you, if you read the problem, it says find the volume of air in the lungs 2 seconds into the respiratory cycle. By substituting 2 into the function, we can find V of 2, the volume of air in the lungs 2 seconds into the respiratory cycle. So here, right here is the equation or the function that was given to you. It was just given to you. You might write it, you might have to write it, but most of the time it's going to be given to you. And they want me to put 2 in because they want me to estimate. You guys, anytime you see V of 2 on the outside, that means like find the Y. Everything is going to be an ordered pair. So basically it says wherever you see a T, because V is over V, T is over 2. So that means I'm going to substitute 2 in for T. Wherever I see a T, I'm going to put a 2. So it's T to the third, so I put a 2. It was T to the second, and it was just T. I plugged it in, I got the answer, and then when you go to write it, you guys, it would be 2, 0.658. Because you guys, you plugged in 2, you got 0.658, it's somewhere on our function. That point is somewhere on our function. Okay. Let's flip it over. Well, I have to flip mine over. I don't know about you. You just have to go to what? To the next little page. Okay. So we're going to use the same equation that we used in that example, but this time we want to know, find the volume of air in the lungs 4 seconds after the respiratory cycle begins, or into the respiratory cycle. So it's going to be V of 4 now. And wherever we see a T, we're going to put a 4 in. And again, we're using the equation or the function that's in the respiratory problem, the respiration problem that on the previous page. So it's going to be negative 0.037 times 4 raised to the third power plus 1.52 times 4 raised to the second power plus 0.173 times 4. So these were all the X's were, these were all the T's were from the previous problem, and now we're going to multiply. Okay, so what I did is I did 4 times 4 times 4 times 0.037, and I got negative 2.368. Okay, then I did 1.52 times 4 times 4, which I got 2.432. And then 0.73 times 4, and I got 2.768. And now what we're going to do is we're going to combine all those. And did you guys get 2.85? Did you guys do it?
I got 2.83.
3.2? Is that what you got?
Yeah.
I got 2. Okay, I did it again, and I got 2.832. Yeah, it always helps to do it twice to make sure you got the same answer. Yes, that's what I got. Is that what you guys got this time around?